So, good day everyone. Today we will be having a video assignment regarding numerical analysis, round-off errors, and computer arithmetic. So, we have three problems here to be solved. So, let's start. So, the first problem is compute the absolute error and relative error in approximations of p by p to the power of asterisk. So, the thing that we will be solving here, or to compute, is the absolute error and the relative error. So, first thing to do is identify first the formula in getting the absolute error and relative error. So, the formula is the absolute value of p minus p to the power of asterisk, and the relative error is the absolute value of p minus p to the power of asterisk over the absolute value of our p. So, as we all know, the p here is known as the exact value, and for the p asterisk is known as for the approximate value. So these two will be used in solving the absolute error and the relative error. So let's start. For letter A, we have p, or the exact value for pi, and the p asterisk, or the approximate value, is 22 over 7. So we will be using the formula absolute error. So this is the formula for absolute error, the absolute value of p minus the p asterisk. So we will just put the, or substitute the values as given from the problem, or given here. So for the A is pi for P, and 22 over 7 for our P asterisk. So pi minus 22 over 7. So as we use our calculator, so the value, or the absolute error for letter A is 1.26449 times 10 to the power of negative 3. So that is the absolute error for our letter A. So next is the relative error. So we will be using the formula also. So here, the absolute value of p minus p to the power of asterisk all over the absolute value of p. So substitute the values. So our p is pi, so pi minus 22 over 7 all over the pi. So using also the calculator, I will get the answer of 4.0250 times 10 to the power of negative 4. So that is the relative error and the absolute error for letter A. So let's proceed. For letter B, so we have here pi for the P, and for the P asterisk is 3.1416. So in letter A, we have a fraction form. So in letter B, our approximate value is in decimal form. So as what we have done in letter A, we will be using the formula for absolute error. So absolute value of p minus p asterisk is equal to, substitute the values, pi minus 3.1416. So we will get the answer of 7.34641 times 10 to the power of negative 6. And then for the relative error, using the same formula, um, for the relative error, so we have absolute value of p minus p to the power of asterisk all over the absolute value of p. So substitute the values. So pi minus 3.1416 all over the absolute value of pi. So we have here 2.33843 times 10 to the power of negative 6. So that is the absolute error and the relative error for letter B. For letter C here, our P, or our exact value is E. Then for letter C here, E. Then for the P asterisk, or the approximate value, is 2.718. So using the formula, absolute value, the absolute For the absolute error, so we will be using the formula absolute value of p minus p to the power of asterisk. So substitute. So our p here is e minus our p to the power of asterisk is 2.718. So we will get the answer of 2.81828 times 10 to the power of negative 4. And last, for the relative error, we'll be using the same formula. So the absolute value of p minus p asterisk all over the absolute value of p. So substitute the same process. So e minus 2.718 all over the absolute value of e. So we have 1.03679 times 10 to the power of negative 4. So next, letter D. So the given is P is the square root of 2 and the P asterisk is 1.414. The same formula again and the same process. So absolute error, the absolute value of P minus P to the power of asterisk is equal to square root of 2, the absolute value of square root of 2 minus 1.414. So we will be having answer of 2.13562 times 10 to the power of negative 4. So next is the relative error. So the formula, absolute value P minus P to the power of asterisk all over the absolute value of P. So equals the absolute value of square root of 2 minus 1.414 all over the square root of 2. So we have 1.51011 times 10 to the power of negative 4. Letter E, our value for our P or the exact value is e to the power of 10, and for the P asterisk is 22,000. So the same process, absolute error is the absolute value of P minus P to the power of asterisk. So e to the power of 10 minus 22,000, then in absolute value. So we have 26.46579. The next is the relative error. We have the formula absolute value of p minus p to the power of asterisk all over the absolute value of p. So we have e to the power of 10 minus 22,000 all over e to the power of 10. So using the calculator, we will be having an answer 1.20155 times 10 to the power of negative 3. Next is f. So the same process for the p, but we have different values for the p and for the p to the power of asterisk. So p is 10 to the power of pi. Then for the p asterisk is 1,400. Then absolute value. So substitute from the formula. So the absolute value of 10 to the power of pi minus 1,400. So we will be having an answer 14.54427. And for the relative error for the letter F is the same formula. So 10 absolute value of 10 to the power of pi minus 1,400 all over the absolute value of 10 to the power of pi. So we'll be having an answer 0.0105. So that is for the letter F. Next is letter G. So here the given is P is equal to 8 factorial, and for the P to the asterisk or for the absolute value or approximate value rather is 39,900. So using the formula, so we have here the difference between 8 factorial minus 39,000 then in absolute value. So we have 420 for the absolute error. And for the relative error, we have here for the formula, absolute value P minus P asterisk all over the absolute value of P. So the absolute value of P factorial minus 39,000 all over the absolute value of 8 factorial. So we have 1 over 96 or 0.010417. So that is for the letter G. And lastly, for our number one, the number one question for the absolute error and the relative error. So the given P is equal to 9 factorial, and then the P asterisk, or the approximate value here, is the square root of 18 pi times to the quantity of 9 over e to the power of 9. So using the formula, absolute error rather, um, the absolute value of p minus p to the power of asterisk is equal to 9 factorial minus the square root of 18 pi times the quantity of 9 over e to the power of 9 in absolute value, so equals to 3,343.127158. So that is for the absolute error. And lastly, for the relative error is using the formula, the absolute value of p minus p to the power of asterisk all over the p, the absolute value of p is equal to 9 pi, and 9 factorial minus the square root of 18 pi times the quantity of 9 over e to the power of 9 all over the 9 factorial absolute value. So we have here the answer is 9.21276 times 10 to the power of negative 3. So maon na siya ang answer for the absolute error and the relative error. So we will proceed to the number 2. So find the largest interval in which p to the power of asterisk must lie to approximate p with relative error at most 10 to the power of negative 4 for each value of p. So in number 2, we will be solving, or we will be computing for the largest interval in which so in number 2, we will be solving for the largest interval in which we have the relative error at most 10 to the power of negative 4. So we have 4 given here, or 4 values of p. So in letter A, we have p is equal to pi. So the formula that we will be using is the bracket, or the quantity of p minus the quantity of p times 10 to the power of negative 4, which is our relative error, um, is lesser than the number, and lesser than the sum of p and the p times 10 to the power of negative 4. So that is the formula of our largest interval. So first, here in the left side, we will just minus the p to the p, which is multiplied already by the 10 minus 4, 10 to the power of negative 4. And then for the right side, we will just get the sum between the p and the p times 10 to the power of negative 4. So let's proceed. Let's just substitute the value for our p, which is in letter A, which is pi. So first, so pi minus the quantity of pi times 10 to the power of negative 4, lesser than the number. And then for the right side, the pi plus pi times 10 to the power of negative 4. So the answer for our letter A, so we have here n the n should be greater than 3.141278 but lesser than 3.141907. So this is the answer for the left side, which is the 3.141278, and the right side is 3.141907. So that is the largest interval for our letter A. And then next, for the next P, or the next value for our P here, is E. So using the same formula, let's just substitute the value for our E. So value for our P, which is E. So E minus the quantity of E times 10 to the power of negative 4, lesser than N, but N is lesser than the sum of e plus e times 10 to the power of negative 4. So the answer is n is greater than 2.71801 but lesser than 2.71855. So that is the largest interval for the p equals to e, which is the letter b. So for the letter c, we have square root of 2. So the same formula, the same process. So substitute the square root of 2. So square root of 2 minus the quantity of square root of 2 times 10 to the power of negative 4. Then the right side is square root of 2 plus the quantity of square root of 2 times 10 to the power of negative 4. So we have here the answer for our letter C, the largest interval. So n is greater than 1.414072 but lesser than 1.414355. So that is the largest interval in the letter C, which is the square root of 2. And then lastly, for the number 2, we have here the p is the cube root of 7. So the same formula, the same process. Substitute the p, which is the cube root of 7. So cube root of 7 minus the quantity of cube root of 7 times 10 to the power of negative 4. And the right side is the sum, which is the cube root of 7 plus the cube root of 7 times 10 to the power of negative 4. So the answer is n is lesser than n is greater than 1.912740 but lesser than 1.913122. So that is for the largest interval for the cube root of 7, which is our p. So that is the answers for that number 2, which has a relative error at most 10 to the power of negative 4. So in number 3, it's just the same. However, we have a different relative error, which is at most 10 to the power of negative 3. The same process, but the formula will be changed in terms of the relative error. So here we have A is equals to 150, and then the formula. So formula is the same from the previous, but we will just be changing for the relative error, which is the 10 to the power of negative 3. So the same process, substitute the value for our letter P, which is 150. So 150 minus the quantity of 150 times 10 to the power of negative 3. And the right side is 150 plus the quantity of 150 times 10 to the power of negative 3. So the answer for the 150 value for our P is n is greater than 149.85 but lesser than 150.15. So that is for the letter A. Next is letter B. So B is equal to 900. And then the same formula, the same process, substitute the letter P, which is 900. So 900 minus the quantity of 900 times 10 to the power of negative 3. Then the other side is the sum. So we will be having an answer of n is greater than 899.1 but lesser than 900.9. So that is for the P is equals to 900. Next is letter C, P is equals to 1,500. The same formula, the same process. So substitute the letter P, which is 1,500. So the difference between 1,500 and the 1,500 times 10 to the power of negative 3, and the right side is the sum for the 1,500 and the 1,500 times 10 to the power of negative 3. So we have the answer of n is greater than 1498 or the 1,498.5 but lesser than 1,501.5. So that is for the 1,500 value of our P. So lastly, for the number 3, we have 90. So formula, the same process also, substitute the 90 or the value of p, which is 99, the left side will get the difference between 90 and 90 times 10 to the power of negative 3, and the right side is the sum for the 90 and the 90 times 10 to the power of negative 3. So the answer here is n is greater than 89.91 but lesser than 90.09. So that is for the number 3 with a relative error of 10 minus 10 to the power of negative 3, and that that is, or these are the largest interval between different values of our p. So that's all for the video assignment, and thank you for listening.